In the last video, we took a look at some limit problems that we could have solved before L'Hopital's rule and see how they worked when we applied L'Hopital's rule. In this video, we're going to take a look at some functions that we would have no idea how to solve if it weren't for L'Hopital's rule. It would just be so much more trouble than it was worth to kind of go through the definitions themselves. And so this will give us a feel for how L'Hopital's rule is a really powerful thing when we're dealing with complicated functions, more complicated than what we were dealing with in previous units. All right, so the first function that we have is the limit as x approaches 1 of the natural logarithm of x over x minus 1. Once again, like I said in the last video, we need to make sure that this is an indeterminate form when we substitute x equal to 1 to make sure that L'Hopital's rule can work. So what does the natural logarithm function look like? Well, the natural logarithm function looks something like this. All right, so as x gets closer and closer to 0, it's approaching negative infinity. And when x is equal to 1, it's equal to 0. And as x approaches infinity, it's approaching infinity, but really pretty slowly. Okay, so the natural logarithm of 1 is equal to 0. And 1 minus 1 is equal to 0. So this is an indeterminate form, so we can use L'Hopital's rule for this. Okay, so what is this equal to? So we're going to take the limit as x approaches 1. It's also a limit. It's going to have boundary points just like before. Now, what is the derivative of the natural logarithm of x? Okay, if you're still looking at your reference sheet to remember these derivatives, that's fine. Remember, the reference sheet isn't going to be there for us when we take the AP exam. So do your best to, when we see things over and over again, make sure you do your best to memorize those. So the natural logarithm of 1 over x is, of logarithm of x is 1 over x, and the derivative of x minus 1, once again, is just equal to 1. So that's equal to the limit as x approaches 1 of 1 over x. And we could substitute 1 in for that, and we just get 1 as our answer. So this thing, which would be, I don't even know how you would go about trying to solve something like this without using L'Hopital's rule. But L'Hopital's rule just spits out 1 as our answer. And because I have faith in L'Hopital's rule, but I don't necessarily maybe have faith yet in my abilities to apply it, let's go look at GeoGebra and see what that function looks like, and we'll see if we should have confidence in the limit that we got. All right, so here is the graph of the natural logarithm of x over x minus 1, and we can see that the limit of this as x approaches 1 is 1, just like the function predicted for us. So good news for us. Okay, so there was one problem. Let's take a look at another one. And this one is going to take a little bit more algebra, but it's a good thing that we have spent a couple years studying algebra. All right, so this is the limit as x approaches 0 of the tangent of x over the square root of x. So pause the video and give this an honest go. Use your reference sheets. You're going to use some trig knowledge maybe. You're going to use some exponent knowledge on this. This is going to be a good test of how much you've got under your belt if you can come up with an answer for this question. All right, let's go for it. All right, so first thing, like before, let's make sure that this is an indeterminate form. So tangent, the graph of tangent looks something like this. All right, so the tangent of 0 is equal to 0. And the square root of 0 is obviously 0. So this is an indeterminate form, so we can use L'Hopital's rule on this. And so this is equal to the limit as x approaches 0. The derivative of tangent of x is secant squared of x over the derivative of the square root of x. Remember that that's equal to x to the 1/2 power. So we can use the power rule on that. So that's saying that that's 1/2 times x. We subtract 1 from the exponent of -1/2. Okay? So is this an indeterminate form? Man, that looks like a lot of work. Let's simplify this and we'll figure out from there if it's an indeterminate form or not. Okay, so first of all, what is secant actually equal to? So secant of x is equal to 1 over cosine of x. This is a good trig identity to know. So what we can do is we can say that this is the limit as x approaches 0. And instead of having secant squared of x in the numerator, we'll make cosine squared of x in the denominator. All right. What about this 1/2 in the denominator? Well, we could move that into the numerator if we take the reciprocal of it. So that 1/2 in the denominator will become a 2 in the numerator. And this x to the -1/2 power, what should we do to simplify that? Well, if we have 1 over x to the -a power, that's the same as moving it into the numerator and switching the sign. So that's going to be x to the a. All right, so notice that we're using all kinds of algebra rules. Some of these you might need to memorize or recall that you once memorized them, depending on your studies up to this point. So x to the -1/2 power in the denominator is going to be x to the 1/2 power in the numerator, which we can just write as the square root of x again. Okay, so using a little bit of algebra, we turned this into something that was less ugly. Now we can see if this is indeterminate or not. So in the numerator, we have 2 times the square root of 0, which is equal to 0. And in the denominator, we have cosine squared of 0. Well, what is the cosine of 0? Remember that cosine looks kind of like this. So the cosine of 0 is equal to 1. So that's 0 over 1 squared. Is that an indeterminate form? No, 0 over 1 is just equal to 0. 0 over 0 is indeterminate. Infinity over infinity is indeterminate. If either one of the numerator and denominator is not 0, infinity, or negative infinity, you definitely don't have an indeterminate form. All right, so this limit, the limit as x approaches 0 of tangent of x over the square root of x, L'Hopital's rule tells us that that limit is equal to 0. And once again, that was a lot of algebra, a lot of places that we could have made a mistake somewhere along the line. So let's go back and take a look at this function in GeoGebra just to double check. You can't do this during a test, obviously, but while you're doing homework, there's nothing wrong with making sure that the answer you came up with is correct. Okay, so this is just for double checking your work using GeoGebra. So here's what the tangent of x over the square root of x looks like. And we can see that the limit at 0 is equal to 0. This is getting closer and closer to 0 as we get closer to 0. Okay, so that gave us an opportunity to look at two functions that calculating the limits without using L'Hopital's rule is beyond our powers. But L'Hopital's rule turns it into something that we can handle. So thumbs up for L'Hopital's rule. We'll take a look at one more example in the next video, and then I'll be able to turn you loose on a couple problems of your own.